Hi, so in this video, let us discuss the difference between synchronous and statistical time division multiplexing. So there are two types of time division multiplexing. One is synchronous time division multiplexing and second is statistical time division multiplexing. Now this synchronous TDM we have already discussed in the previous video. So in this video, we will discuss the difference between synchronous and statistical. So the first difference in synchronous and statistical is that in synchronous there are reserved slots in output frame, whereas in statistical there are no reserved slots in the output frame. So this is the diagram for synchronous time division multiplexing and this is for statistical time division multiplexing. So as discussed in the previous videos, we know that for synchronous time division multiplexing, for the first time duration, these data units will be sent as frame 1 and for the second time duration, these data units will be sent as frame 2. And in statistical time division multiplexing also, for the first time duration, these data units are sent as frame 1 and for the second time duration, these data units are sent as frame 2. But in synchronous time division multiplexing, for each input line, the slots will be reserved in the output frame. For example, this slot is reserved for line A, this is reserved for line B, this is reserved for C, this for D, and this is reserved for line E. Similarly, in this frame also, the slots are reserved for each input lines. But in statistical time division multiplexing, for each input lines, there are no reserved slots in the output frame. So the slots are dynamically allocated based on the data sent. So the second difference between synchronous and statistical is that first in synchronous, if there is no data on the input lines, then the corresponding output frame slot is empty. So if the input lines have no data to send, then there will be empty slots in the output frame. Whereas in statistical, there are no empty frame slots and frame slot is allocated only when input line has data to send. That is, there will be dynamic allocation of slots. So let us understand this difference with the help of these diagrams. So in this figure for synchronous time division multiplexing, we can see that line C has no data unit to send. Similarly, line A has no data unit to send for the second time duration. Similarly, line E has no data unit to send for the first time duration. So for the first time duration, these data units will be sent as frame 1. So over here we can see that in this frame, the slots reserved for line C and line E are empty because line C and line E is not sending any data unit. Similarly, for the second time duration, this data units will be sent as frame 2 and in this frame we can see that the slots reserved for line A and line C are empty because line A and line C is not sending any data for the second time duration. So these two slots will be empty. Whereas in statistical time division multiplexing, frame slot is allocated only when input line has data to send. So over here in frame 1, slots will be allocated only for lines A, B and D because only these three lines, that is A, B and D, have data units to send. And similarly in this frame, slots will be allocated only to lines B, D and E because only B, D and E have data to send for the second time duration. So over here in statistical time division multiplexing, we can see that there are no empty slots. So that was the second difference. The third difference is that synchronous time division multiplexing is less efficient, whereas statistical time division multiplexing is more efficient compared to synchronous. So we can say that synchronous time division multiplexing is less efficient because whenever the input lines have no data to send, the corresponding slots in the output frame is empty, so which will waste the space. Whereas in statistical time division multiplexing, even when the input lines have no data to send, there are no empty slots because the slots are located dynamically. So as a result, it is more efficient as compared to synchronous time division multiplexing. So the next difference is in synchronous, the number of slots in the output frame is same as that of the number of input lines. Whereas in statistical time division multiplexing, the number of slots in the output frame is not same as that of the number of input lines. So in synchronous time division multiplexing, we know that for each input lines, there will be slots reserved in the output frame. Now over here, we can see that there are 5 input lines, that is A, B, C, D and E. And for each of these lines, there will be slots reserved in the output frame. So if there are 5 input lines, there will be 5 slots in frame 1. Similarly, in frame 2, there will be 5 slots. So we can say that in synchronous time division multiplexing, the number of slots in the frame is same as that of the number of input lines. Whereas in statistical time division multiplexing, for each input lines, the slots are not reserved in the output frames, whereas the slots are allocated dynamically. As a result, the number of slots in the output frame will not be the same as that of the number of input lines. But in rare cases, if all the input lines have data to send for all the time duration, then in that case, the number of slots in the output frame can be same as the number of input lines, but that will be only a rare case. So most of the times, number of slots in the frame is not the same as that of the number of input lines. The next difference is in synchronous time division multiplexing, address is not included in the output frame, only data is sent, whereas in statistical time division multiplexing, the output frame includes address as well as the data. So over here in this figure of synchronous time division multiplexing, we can see that address is not included in the output frame, only data units are sent. So these are only the data units. Now in synchronous time division multiplexing, addressing is not required because the frames are already synchronized and also there are reserved slots in the output frame. Whereas in statistical time division multiplexing, the output frame will include the address and data for each slot. So over here in this figure for statistical time division multiplexing, we can see that for each slot the output frame will carry the address as well as the data. So again this is the address and this is the data. So similarly over here this is the address and this is the data. Same way for this frame also, the address and the data units are sent. Now this addressing is important in statistical TDM because there are no reserved slots and we need to include the address of the receiver inside each slot to show where it is to be delivered. The last difference is in synchronous TDM, synchronization bits are required, whereas in statistical, the synchronization bits are not required. So in synchronous time division multiplexing, these are the synchronization bits which are included at the beginning of each frame, and the synchronization bits are required in synchronous TDM to provide synchronization so that the data units are received by the correct channels. Whereas in statistical TDM, the synchronization bits are not required because here we are sending the address.